Good morning. So today I am going to discuss magnetic property of solids. Okay, so it is magnetic properties of solids. Okay, and we have to discuss the reason behind the magnetic properties of a solid. Okay, so what happens, there are electrons, okay, present in a solid. So these electrons have magnetic moments associated with them. Okay, electrons have magnetic moments associated with them. Okay, this magnetic moment in electrons or associated with electrons is due to its orbital motion and spin motion. Is due to its orbital motion and spin motion. Okay, the fundamental unit of magnetic moment is Bohr magneton. Bohr, B-O-H-R, Bohr magneton, and it is given by mu b is equal to 9.27 okay, into 10 to the power minus 24 am square. Okay, so what is magnetic properties of solid? I told you magnetic properties of a solid, okay, is due to the presence of electrons in solid. Okay, and what happens, these electrons have magnetic moments associated with them. Okay, these magnetic moments in electrons are due to, okay, so this magnetic moment associated with electrons is due to its orbital motion and spin motion. Okay, we know this. Electrons revolves around the nucleus in circular path called as orbit. Okay, and a space in the orbit where probability of finding an electron is maximum, we say it is up to 95%, okay, is known as orbital. So orbital means what? Electrons are means revolving. Electrons are revolving, and that is known as orbital motion. Orbital motion. Okay. And also electrons have some kind of spin associated with this. Spin you can simply means you have studied this in class 11th. Okay, means if one is in clockwise direction, then other will be anti-clockwise direction. So it is moving, or we say spinning. Okay, so due to the spinning of electron and due to the orbital motion of electrons, okay, some kind of magnetic moments gets associated with them. Okay, now fundamental unit, the fundamental unit of magnetic moment. What is magnetic moment? I told you. Okay, so unit of fundamental basic unit of magnetic moment, okay, is Bohr magneton. Is Bohr magneton, and it is given by mu b, and it is equal to 9.27 into 10 to the power minus 24 am square. Okay, now just I am rubbing this. So say electrons are revolving. Okay, and this is the magnetic moment. This is the magnetic moment. Magnetic moment, direction of magnetic moment. Direction of magnetic moment. Okay, so so this is direction of magnetic moment. Okay, and here we say it is orbital motion. We say this is figure A. This is figure A, and figure A is the orbital motion, and due to the orbital motion magnetic moment is associated with this. So this is figure A, and in this figure we say orbital motion of electron, and due to orbital motion of electron, okay, magnetic moment is associated with this. Okay, in second figure here electrons are spinning. Okay, and due to the spinning of electrons, magnetic moment is associated with this. So here it is in this figure, spinning of electron is shown. Okay, it means spin motion, okay, means magnetic moment of due to spin motion is given by magnetic motion due to spin motion is given by magnetic moment due to spin motion is given by plus minus mu b, is given by plus minus mu b, means it depends upon the direction of rotation. Okay, if you will consider clockwise to be plus, then anti-clockwise will be minus. So plus minus b, and simply it is represented as like this. Okay, one is just opposite of second. Okay, so if you will consider this plus, then it will become minus. So say if this is plus mu b, then this will become minus mu b. Okay, and magnetic moment due to orbital motion of electron is given by it is ml into mu b. Okay, where ml is spin quantum number, where ml is equal to spin quantum number. Got this? There is one formula, okay, to calculate magnetic moment, and I am going to write the formula. It is mu is equal to n into n plus 2 under root. Okay, mu is calculated by the formula mu is equal to n into n plus 2. Okay, and this value is under root. Okay, where this n is what? This n is number of unpaired electron. This is the formula for finding magnetic moment, and we say here n is equal to number of magnetic moment, number of unpaired electrons. Okay, so these were very basic things, okay, fundamental things. Now we will be discussing types of magnetic properties of solid. Okay, so we have to discuss basically 5 properties, okay, 5 magnetic properties, and these are paramagnetic behavior, diamagnetic behavior, then ferromagnetic behavior, then antiferromagnetic behavior, and ferrimagnetic behavior. Okay, so these are paramagnetic, okay, then diamagnetic, then ferromagnetic, then antiferromagnetic, and ferrimagnetic. So we have to discuss paramagnetic, diamagnetic, ferromagnetic, antiferromagnetic and ferrimagnetic one by one. Okay, so these are 5 different magnetic properties shown by different solids. Okay, so just start with paramagnetic. Okay, so right here paramagnetic. Substances. So these substances are weakly attracted, or we say these substances are attracted towards magnetic field. Okay, or simply these substances are attracted towards magnets or magnetic field. Okay, first point is these substances are attracted towards magnetic field. Now come to what is paramagnetic. So paramagnetic substances possesses unpaired electrons. Paramagnetic substances possesses unpaired electrons. This is very important point whenever it comes to paramagnetic. Okay, then paramagnetic will possess unpaired electrons. Okay, now when magnetic field is applied, okay, on these substances, the electrons or substances, or we say the electrons or the magnetic moment of the electrons, comma, the magnetic moment of the unpaired electrons aligns themselves in the direction of magnetic field. Okay, due to this a magnetic behavior gets introduced in these substances Okay, getting this? Due to this magnetic behavior gets introduced in this substance. Now it is okay. It was not looking good. Okay, so I am taking some examples. I am taking some examples of paramagnetic substances. Okay, so the examples of paramagnetic substances. Okay, we say it is say it is cobalt. Say it is cobalt, nickel. Just I am explaining why these substances are paramagnetic. Okay, so say it is cobalt. So cobalt, okay, means atomic number of cobalt, I think it is 27. Okay, so when you will write electronic configuration of cobalt, then it will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d7. Okay, sorry, 3d7. 2, 4, 10, 12, 18, 20, 27. Okay, this is the electronic configuration of cobalt. Okay, so just draw outermost orbitals, diagram of outermost orbitals. So this is 4s2 and 3d7. So 4s2 means 2 electrons are present in 4s orbital. Okay, now come to 3d7, 2, 3, 4 and 5. Okay, so 3d7 means 7 electrons are there and electrons are filled one by one, 1, 2, 3, 4, 5. Okay, now 6, 7. So from this configuration you can clearly, okay, you can clearly say there is 3 unpaired electron in case of cobalt. Means unpaired number of unpaired electron, number of unpaired electron in cobalt is equal to 1 to 3. Getting this na? And I told you paramagnetic behavior is just because of the presence of unpaired electron. So we can say this is example of paramagnetic substances. Okay, you can find its magnetic moment using the formula I told you na, unpaired electron 3, 3 plus 2 under root, like this, na? You can calculate this. Okay, take other example. Say it is cobalt, nickel. Say it is nickel. So nickel, atomic number of nickel is 28. Okay, so things will be same up to this. Means this is electronic configuration up to 18. So I am just writing here nickel will be argon up to 18. Okay, then 4s2 and 3d8, 4s2 and 3d8, 8 plus 2 10, 18 plus 10 28. Okay, so outermost, draw outermost orbital diagram. It will become 4s2 means 2 electrons are present in 4s, then 3d8, 1, 3, 4 or 5. Okay, so it is 3d8, means 8 electrons are present. So 1, 2, 3, 4, 5. Then 6, 7, 8. So in this case, unpaired electrons are 2. Unpaired electrons are 2. One more thing, cobalt have 3 unpaired electron and nickel have 2 unpaired electron. So the species having more unpaired electron will show more paramagnetic behavior. Okay, and you have to remember one thing, oxygen. Okay, just draw oxygen. Oxygen is OH, so 1s2, 2s2, 2p4. Okay, don't do this. Okay, here MOT, molecular orbital theory, is used. Okay, so don't get confused. Okay, so you can do it by yourself. Okay, the species having unpaired electron will show paramagnetic behavior. Now come to diamagnetic behavior. Okay, or diamagnetic substances. So write down diamagnetic substances. These substances are weakly repelled. These substances are weakly repelled by magnetic field. Okay, second thing, this property or magnetic property, okay, is due to presence of paired electrons. Okay, so it is opposite of paramagnetic substances. Okay, so in case of diamagnetic substances, what happens? There is no unpaired electrons present. There is no unpaired electron present, means only paired electrons are present there. Okay, so examples, you can say it is NaCl. Okay, NaCl is the example. Then you can say N2. N2 is also diamagnetic. Okay, how N2 is diamagnetic? Means if you will draw nitrogen, then it will become 7, means 1 S2, 2 S2, 2 F3. Okay, so one nitrogen is having this electronic configuration and 2 nitrogen is there, means second nitrogen will also have 1 S2, 2 S2, 2p3 electronic configuration. Okay, now only those electrons or only those orbitals takes part in we say reaction, okay, or in bond formation, which is half filled. So 2p3 and 2p3, just draw it. This is 2p3, means 1 electron, 2 electron and 3 electrons. So this is 2p3 of first nitrogen. Okay, so what happens? We have N2, means 2 nitrogen, so this 2p3 will form bond, okay, by pairing up electrons here like this. So 2p okay will form bond, means it will be triple bond. Okay, two bonds are pi bond, two bonds are pi bond, and one bond is sigma bond. So from here you can say, okay, no unpaired electron is present here, so N2 is diamagnetic. But when it comes to oxygen, O2, when it comes to O2, then O2 is not a diamagnetic substance. Just try to remember this, okay. O2 is like N2, O2 is not diamagnetic. O2 is not diamagnetic. Okay, O2 is not diamagnetic, it is paramagnetic. It is paramagnetic. Okay, according to molecular orbital theory. Molecular orbital theory. So is it clear to you? Okay. Now come to ferromagnetic substances. So put heading ferromagnetic substances. Okay, so right here some substances like cobalt, nickel, iron, CrO2, etc. are strongly attracted by magnetic field. Okay, so the term here used is are strongly attracted. It is not attracted simply, it is strongly attracted. In case of paramagnetic, I told you these are attracted towards magnetic field, but in case of ferromagnetic we say these are strongly attracted. Got it? Okay. Now actually what happens in solids, the metal ions present in solids, the metal ions are present. Okay, in solids the metal ion are present in a group, in a small group together, known as domains, 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 domains. Okay, so in solids the metal ion present okay, are in a present are in a small group, okay, and these small, or we say in small range, it is okay, and these are known as domains. So what happens when magnetic field is applied? When magnetic field is applied, these domains, what is domain? Domain is simply the metal ions which are grouped together in a small region, So when magnetic field is applied, this domain, okay, these domains are or gets aligned in the direction of magnetic field, of applied magnetic field, direction of applied magnetic field, okay. So when magnetic field is applied, these domains gets aligned in the direction of applied magnetic field. Therefore making or magnetic field, and we say next in write in next line, okay. In this way the magnetic moments, okay, due to all domain gets added and makes the substance magnetic in nature. Getting this? This is, in this way the magnetic moments due to all domains gets added, okay, and makes the substance magnetic in nature, okay. You just if you are getting confused, then I am just defining domain here. Domain is the metal ions grouped together in a small region, Getting this? This is we say definition of domain. What is domain? Domain is the metal ions grouped together in a small region, okay. Now one more thing regarding ferromagnetic substances. Even after removing the external magnetic field, after removing the applied external magnetic field, these substances behaves as a magnet. Okay, so these show or these are also called as permanent magnets. Okay, these are also called as permanent magnets. Okay, you can simply do it by yourself at your home. Okay, take a magnet, okay, and take a nail and simply just touch the magnet, okay, on the nail. Then what will happen, it will get attracted, okay, and as you will, after some time you will, okay, remove the magnet, then still you can see the nail is showing some kind of magnetism. Okay, so these are known as ferromagnetic substances. Okay, and these substances are strongly attracted by magnetic field. Okay, now come to antiferromagnetic substances. And means in this case what happens, one more thing, I am just making diagram. So say these are domains, and you can see all are aligned in one direction, in a single direction. So what happens, since they are aligned in single direction, so net magnetic moment increases. Okay, and due to which these are, we say, these behaves as strong magnets. Now come to antiferromagnetic substances. Okay, so what are antiferromagnetic substances? Write down antiferromagnetic substances. So antiferromagnetic substances, okay, antiferromagnetic substances magnetic substances, okay. So what happens, the domains present okay on application of external magnetic field, the domains present on application of external magnetic field arrange themselves in such a way that they cancel magnetic moments of each other. Getting this point means what happens in this case? In this case, the domain present, okay, on application, when you will apply, okay, external magnetic field, so the domain present on application of external magnetic field arrange themselves in such a way, okay, that they cancel magnetic effects of each other. Okay, what does this mean? I am simply making diagram. So suppose if one is in upward direction, then other will arrange itself in downward direction. Again, if one is upward direction, then other will be in downward direction, in the way upward, downward. So 1, 2, 3. 3 are in upward direction and 1, 2, 3 are in downward direction. So what happens? These nullifies, okay, effects of each other, or magnetic moments gets cancelled, okay, due to alignment, due to their alignment. Means if it is in upward direction, this is in downward direction, so this is nullifying, okay, its effect. Getting me now? So in this way we say, means the domains the domains align themselves in the way that the magnetic moments of each gets cancelled. Okay, and these are known as antiferromagnetic substances. These are known as antiferromagnetic substances. So the domains present on application of external magnetic field arrange, or you can say a better word is align. Okay, arrange is okay, but align will be more suitable word. Align themselves in such a way that they cancel magnetic moments of each other. Means what? To conclude, the net magnetic moment here is 0. The net magnetic moment of these substances is 0. This is very important. Okay, the net magnetic moment in this case becomes 0. Okay, that's why, okay, these are called as anti-ferro. Anti means opposite of ferro. Okay, now come to write one example. We say MNO is example, okay, of antiferromagnetic substances. Okay, now last one is ferromagnetic substances. And what are ferromagnetic substances? Simply, in case of ferromagnetic substances, what happens? Right here, ferromagnetic substances. So the domains present in these substances, align themselves the domains present in these substances on the application of magnetic field, we say external magnetic field, align themselves in such a way that align themselves in such a way that their align themselves in parallel and anti-parallel manner, in parallel and anti-parallel manner, anti-parallel manner. Okay, align themselves in parallel and anti-parallel. Happens. One more point, the net magnetic moment in this case is greater than 0, but lesser than magnetic moment in case of antiferromagnetic substances. Antiferromagnetic substances. Getting this? This time, what will happen? Domains will arrange themselves in parallel and anti-parallel manner. Okay, these are domains. Domains will arrange or align themselves in parallel and anti-parallel manner. So, say if it is in upward direction, so opposite will be in downward direction. If it is in upward direction, then opposite will be in downward direction. Okay. Upward direction. Okay, so you can see here, this magnetic moment is cancelled by, effect of this magnetic moment is cancelled by this we say effect of this magnetic moment is cancelled by this, but one or more magnetic moments will be present there, means they are not getting cancelled out. Okay, so some are getting cancelled out, but some are left there, which contributes in net magnetic moment. So the net magnetic moment in this case is greater than 0, but lesser than magnetic moment in case of antiferromagnetic substances. This is very important line. Okay, now we can say we have almost discussed all of the magnetic substances, magnetic behavior of substances. Okay, so we are left with temperature, effect of temperature on magnetic behavior of solid, and then simply it is dielectric constants. Okay, so in next video, it will take hardly 20 to 25 minutes, and in next video we will finish this chapter. Okay, actually I was supposed to finish it by today. I was expecting this, but it will take 25 to 30 minutes more. Okay, so in next video we will finish this, and we will doing some numericals. Okay, thank you.